Okay, here we go. This is our last lesson for quadratic equations, and our objective is I can solve and graph quadratic equations using intercepts and vertex. Let's read together. 1, 2, 3. I can solve and graph quadratic equations using intercepts and vertex. So we're still on the same concept, quadratic equations. That's why we don't need a Ferrier model. Today we're looking still at intercepts. But something that we're really going to focus on is on the vertex, okay? So at the beginning of the year when we did some graphing, I showed you that the highest and lowest points of a parabola were the vertex, okay? So we know that quadratic equations are. Copy these tiny steps. It's only 7. So step 1, make sure the quadratic function is in y equals ax squared plus bx plus c form, which is standard. Use the quadratic formula to find out the number of solutions. Use the quadratic formula to solve for the x value of the vertex. Substitute the x value of the vertex into the function to find the y value of the vertex. Solve the equation and identify the zeros. Plot your y-intercepts, zeros, and vertex and graph your function. And at the end, sketch your line of symmetry. Copy those. Alright, here we go. So, most of these steps we already know how to do. The only one that we need more clarification is on the vertex. Okay? So, copy this step, this example, copy it in the back so you can have enough room to make all the steps. So, it says, example 1, solve and graph the quadratic equation using the vertex, x-intercepts, and y-intercept. The equation given is y equals x squared plus 4x minus 5. And let's get started. Step number 1, or the very first thing that we do with quadratic equations, we substitute what? 0 for y. So this becomes 0 equals x squared plus 4x minus 5. So now, step 1 says check to see if it's in standard form. Is it in standard form? Yes. So step 1 is done. Step 2 says, I'm going to write over here to the right, use the quadratic formula to find how many roots you're going to get or how many solutions you're going to get. So first I'm going to write my quadratic formula. X equals minus b plus minus square root b squared minus 4ac over 2a. So from there, I'm only going to use whatever's inside the square root or the radical, and that's what we call the discriminant. So I'm going to use b squared minus 4ac. So now let's substitute values and find out what we get. So what is b? 4, so this becomes 4 squared minus 4. What is a? 1. And what is c? Negative 5. So let's simplify that. This becomes 16, negative 4 times 1 is negative 4 times negative 5, that's plus 20. So 16 plus 20, that's 36. So right now we're looking at the sign of this number. This number is a positive number. So whenever we end up with a positive number, we are always going to get 2 roots or 2 solutions. So according to what we just did, how many solutions are we getting? 2. However, let me show you the other option. The other option would be if we get a negative number, therefore it would be 0 roots, or that means there are no solutions. The third option and only option would be, so first option is a positive number, second option is a negative number. The third option is if this number ended up being 0. If the number was not a positive or a negative, it ended up being a 0, our answer would be 1 root, only 1 solution. Remember those graphs that you see the parabola and it barely touches the x-axis? That's the kind that would be with 1 root. Are we there? So now that we know, this is just to tell us how many solutions we're going to get at the end. So how many at the end? 2, right? All right, so we're done with that. But right now where I want to focus our attention to is steps 3 and 4, which is the vertex. Write that underneath here, the vertex. For the vertex, we need a point. Open up parentheses. We need an x value, and we need a y value. For the x value, we're going to use part of the quadratic formula again. That's why I wrote it over here. But look, this part, the part that I'm going to use this beginning part down here and that. And I call it the California part because it looks like a slanted California. You guys see it?
Looks like Texas. Oh, no.
So what would I write? I would write x equals minus b over 2a. X equals minus b over 2a. And that's going to give me the value of the vertex. So let's see. Let's substitute values in here. What was b? 4. So this is negative 4 over 2 times a, which is 1. So this is negative 4 over 2, which is negative 2. That goes right there. So what? I need to clean out my computer. It's got a lot of videos already in it.
Oh, so you're gonna like do...
Yeah, it's space. All right, so here we go. So what am I missing? I'm missing a what? A y value, ain't I? So think about it. Don't say it out loud. They gave us this equation originally. Look up. And now I have an x value. How can I find a y value? Some of you are thinking, well, if I take this equation and I write it over here, y equals, but instead of x, what would I write? Everyone? Negative 2. That is true. That's how we're going to get our y value. So this is y equals 4. This is plus 4. 4 times negative 2, that's negative 8, minus 5. Y equals 4 minus 8, that's negative 4. Negative 5, that's negative 9. So that's my y value, negative 9. So the vertex is at negative 2, negative 9. Hold on. So step 3 was here for the x value. Step 4 was here with the y value. Okay? So, from there, step 5, we're going to solve this equation. We already know 5 different ways on how to solve it. But right now we're going to solve it by factoring. So if I was to solve this by factoring, what do? Open 2 parentheses, factor the first term, x and x. Power Rangers, we got negative 5, positive 4. What factors of negative 5 add up to 4? Negative 1 and positive 5. So this is x minus 1, x plus 5, and all that equal to 0. At that point, we said each factor equal to 0, x minus 1 equal to 0, x plus 5 equal to 0. Let's solve. Therefore, this is plus 1, x equals 1, minus 5, x equals negative 5. So those are my solutions. Did we get 2 of them?
Yeah.
Did we predict that at the beginning?
Yeah,
we saw that it was a 36, so we got 2 roots. There they are. That's why these are called the solutions. X-intercepts, zeros, roots. So we got 2 solutions. So now, we're going to use all this information to graph our parabola. Because it said here, use the vertex. Do we have the vertex? Yes. X-intercepts. Do we have x-intercepts? Yes. Y-intercept. Do you know what the y-intercept is? Yes, negative 5. So we have all that information. So let's draw our coordinate plane over here. All right. So the first x-intercept is 1. 1 is about right here. The other one is negative 5. 1, 2, 3, 4, 5. So therefore, we got negative 5 right here, 1 right here. My y-intercept we said was negative 5, so we got 1, 2, 3, 4, 5, which is right there. Alright, what are we missing? Oh, the vertex. That's what we said we were going to focus on. So what is my vertex? Negative 2, negative 9. So see, negative 2 is about right here. Negative 9 is down here, so negative 1, 2, 3, 4, 5, 6, 7, 8, 9. So the vertex is about right there. Does everybody follow?
Yeah.
So what does that mean? That at this point, the parabola is going to go back up. Everybody with me? So here we go. So let's start on the far left. So let's start going down. When you start getting close to the vertex, make sure you start curving to come back up. We're going down. We start curving, and now we turn, come back up, go through the y-intercept, and through the other root. And that's our parabola. Now we're a little bit more precise. Do you notice that?
Yeah.
Where before it was just like, and that's it, right? So there's a couple of things that I want to show you really quick, and tonight's home play is going to be just solving one equation like this. That's it. You already know how to do everything. The only thing that you needed to see was the discriminant and the vertex. Are we there? So now check this out. Let me show you some patterns here. First pattern that I want to show you is something that we call the line of symmetry.
Oh, we know that.
Right, so watch. If I was to draw, look at the x value of the vertex, what was it? Negative 2. If I draw a line down negative 2, that creates a line of symmetry. Now, what is that? Let me explain it. I'm pretty sure some of you, every now and then, have looked in the mirror, right?
Oh, yeah.
Now, if you are like me, sometimes you have extra time in your hands and you're right there in front of the mirror, and then all of a sudden you start tripping out that the distance from where you're standing to the mirror, and all of a sudden you look at the image inside of the mirror, and you can see the distance also inside of the mirror. It's the same distance from you to the mirror. Have you guys ever tripped out on that? Watch. When you look in the mirror, like some of you never thought about it till right now, you are certain distance away from the mirror. Are we there? But if you look at the image and inside of the image of yourself in the mirror is the same distance of you outside of the mirror. You know, some of you are like, what? I thought I was just right there in the mirror. No. Everything is the same distance away from the mirror. That's the line of symmetry. So what does that mean? So if you're standing in the mirror, and you just woke up in the morning with like a lot of like saliva or like dried up over here on the side, you're about to start like cleaning yourself, and you can see yourself that you're like 2 feet away from yourself, from the mirror. The image inside is also 2 feet away if you actually look at the depth of that image. I know, what a trip, huh? And that's what the line of symmetry is. What it is that everything on the right side, on this side of the mirror, is the same distance from the left side of the mirror. Watch. Trip out on this. Look at this point. How many steps is it away from the line of symmetry? 1, 2, 3. So if there's a point over here, there has to be another point over here 3 steps away. 1, 2, 3. Everybody see that? Do we have another point over here? Yes. How many steps is it away from the line of symmetry? Let's see. 1, 2. Therefore, there has to be a point 2 steps away on the other side. Plot that point, please. That's what the line of symmetry does. Furthermore, what was the x value of the line of symmetry or the vertex? Negative 2. Now watch. Look what I'm going to do. Look at this x-intercept. And look at this x-intercept. You have negative 5 and positive 1. That becomes what?
-4.
And then how many distances do we have away? One side on this side, one side of it. That's two different sides.
Whoa! Oh my God!
Did everybody see what I did?
Yes.
For those of you that didn't see it, another way of finding the x value is if you find your roots, you add those together and divide by 2. That gives you the x value of the vertex.
Oh my Lord! No way.
Yes? Everybody got it? So, for tonight, I want you guys to solve y equals, this is your home plate, y equals x squared plus 5x plus 6. And I want you to use the process that we just did right now.
Yes, Mr. Q.
Everybody got it?
Yeah.
Alright, have a good one, guys. Enjoy your home plate. See you guys tamales.